Hello students, welcome to the amazing platform of Physics Wallah. Welcome to the PW English channel, my dear students. So today, till now, we have covered the solid state chapter completely. We have discussed everything about it. Now, my dear students, we are going to start a new chapter, which is surface chemistry. So today we will be starting a new chapter, surface chemistry, which is a very important chapter actually, because till now whichever chapter we have studied, all of them had actually a numerical point of approach, right? Yes, a lot of numericals can be expected from all the chapters which we have discussed till now. But let me tell you, the surface chemistry chapter is such a chapter which is completely theoretical, and there is nothing a lot numerical related part in this particular chapter. This chapter is completely theoretical, so you only have to listen to each and every point very seriously, because questions will be asked from the theory, right? Yes, so you need to write the notes very well. You need to go through each and every point very well, because it is a theoretical chapter, and for this particular chapter NCERT is very, very important, right? Yes, just let me give me 1 second, my dear students, just give me 1 second. Yes, okay, perfect. Now we can start our session. So what are we going to cover today? Today, my dear students, we'll be discussing about adsorption. What exactly is adsorption? Then we'll discuss about the different types of adsorptions, and then we'll discuss about the French-Lich adsorption isotherm. These are the few things that we will be covering today. So I hope all of you are excited. So let's start the session. So now, my dear students, for starting this session, my first question to each and every one of you is that we have heard two words. One is absorption and the other is adsorption. So if I ask you what is the difference between these two words, what will you say? One is adsorption and the other is absorption. Okay, so if we focus on in here, we say that, ma'am, this is a word where we have a B here, and this is a word where we have just the mirror image of what we have written there. That is the mirror image, that is D, right? Yes, these both differ only in this particular part. So ma'am, maybe you might have written it wrong, right? Yes, maybe these are same words, but by mistake you just wrote B to B, you replaced it by D. No, actually, my dear students, this single word change has actually changed the complete meaning. Now let's try to understand the difference between absorption and adsorption. Okay, so imagine you are working on your study table, okay, and your mother brought tea for you. Okay, what happened? You by mistake you spilled that tea. Okay, so now you have two options. You have a wooden box there. Okay, you have a wooden box there on your table, and also you have a tissue paper on your table. Which thing will you use to remove that coffee or tea, that spilled tea and coffee? You will say that, ma'am, we'll definitely use tissue paper. Okay, fine. So now my question to you is, why tissue paper? Why have you used tissue paper and not the wooden box? Because, ma'am, tissue paper would easily absorb it, will easily absorb the tea, and it will remove it, right? Yes, that is my answer. That is my basically the question, that why you used the word absorption. Why didn't you use the word adsorption? What is the difference between absorption and adsorption? Now let me give you one more phenomena. You all have now you all go to the school, right? Yes, and you have whiteboards there, that blackboard, and with a black or green board, and your teacher writes with the white chalk there. Yes, and she uses a duster. Yes, and you erase that part with the duster. Yes, and then you erase it, and then you go out of the class, and you just try to get out that white part. Yes, what actually happened? You used that duster, though that chalk got removed, and when you went out and you just tried to get off that white chalk, it just went off. Okay, was that absorption? If that was absorption, if your answer is yes, then can you just use that tissue paper to remove the tea and go and just remove the tea from the tissue paper like you used for the duster? No, you cannot. No, you cannot. So, my dear students, what I want to tell you here is these two phenomena are completely different. The first, where you use the tissue paper to clean the tea, that was absorption, because the tea went into the bulk of your tissue paper. That is, the things that get into the body of the other material which we use. For example, we use tissue paper. The material which goes inside the body, that is the bulk part. The complete body part is the bulk part, and the tea is absorbed inside the body. But when we talk about the duster phenomena, what happened there? Only and only the chalk particle got stuck on the surface, and when you try to remove it, it was on the surface, it got removed. And that process where your one part is getting only added on the surface, that is known as adsorption. So can I say that adsorption is a surface phenomena, whereas absorption is a bulk phenomena? So your absorption is a bulk phenomena. It is a bulk phenomena. Okay, I am sorry. It is a bulk phenomena. And when you talk about adsorption, it is a surface phenomena. You all might have seen that cartoon where, let's say this is water, and let's say this cartoon is here. I'm trying to draw it. Just let me see if you can, guess or not. This is SpongeBob SquarePants. Okay, so this is SpongeBob. What you did, you just got this SpongeBob inside the water, and now your SpongeBob is like this. Why? Because it has absorbed the water. It has absorbed the water in the bulk. Okay, so this is absorption and not adsorption. Okay, adsorption occurs only on the surface, whereas absorption occurs in the bulk of the system. Okay, yes, so this is the basic difference between absorption and adsorption. We will be studying about adsorption. Okay, yes, please write it down, then we'll move forward. Okay, now let's write the definitions. Let's write the definition of adsorption. It is a surface phenomena. It is a surface phenomena. Accumulation of particles on the surface is known as adsorption. Okay, now let's try to write the definition of absorption. First thing is, it is a bulk phenomena. Accumulation of accumulation. What spelling have I written, right? Yes, accumulation of particles in the bulk is known as absorption. So we will be studying adsorption, not absorption, but you need to know the difference between the two. You can pause the video, write it down, then we'll move forward. Okay, I hope you've written it. Now, my dear students, there are a few terminologies which we'll be using again and again. So you need to have a better understanding of each terminology. The first is adsorbate. So how can you understand adsorbate and adsorbent? I hope all of you know that how a solution is made. A solution is made by a solute and a solvent. When you add solute to the solvent, your solution is made. Yes. Now, you know that your solvent is a large part and your solute is actually the smaller part. You have solute which you add into the solvent and you get a solution. So I hope everyone knows the difference between a solute and a solvent. So using this, we can understand adsorbate and adsorbent. Okay, we can understand adsorbate and adsorbent. Okay, perfect. Now let's try to understand our adsorbate and adsorbent. See, my dear students, when you talk about adsorption, obviously there are the particles which get stuck on the surface. Okay, let's say I have this surface, and let's say some particles are getting adsorbed. So the particles will be adsorbed. So you have two different particles. One is getting adsorbed and the other is providing a space for the adsorption. So we have to find the difference between the two. The one that gets adsorbed on the surface is known as your adsorbate, and the one that provides the surface for the adsorption to occur, that is known as adsorbent. Just a second, you need to correct it here. This should be adsorbent. Okay, now how will you understand? See, solution has ENT in it. Yes, and solvent has ENT in it, and solvent provides the medium for the solute to come and get dissolved in it. Similarly, your adsorbent provides the surface for the adsorbate to come and sit on it. So you can understand by this ENT, your solvent also has ENT. Okay, so can I say that your adsorbate, adsorbate is the how should I define it? Let's say adsorbate gets adsorbed on the surface. The particles being adsorbed on the surface are known as adsorbate. Okay, and the substance which provides a surface for adsorption is known as adsorbent. Okay, perfect. Yes. What is desorption? What is desorption? The removal of the particles from the surface. That is the opposite of adsorption is desorption. So can we say that opposite of adsorption is desorption? Okay. Now, my dear students, after this, one question should arise in your mind. And the question is, why adsorption happens? What is the reason that particles get adsorbed on the surface? Why does this happen? So now we need to understand that why adsorption occurs. So now, my dear students, to understand this, what you have to understand is you have to consider a surface. Let's consider a surface like this. Now we know that particles are present everywhere. Your particle will be present here as well. I'll draw it with pink. Your particle would be present in the bulk as well, and your particle would be present on the surface as well. So I have drawn only two particles, one in the bulk, that is inside the body, and one on the surface, that is your surface particle. Now, if I talk about this particular particle which is in the bulk, see my dear students, it will be attracted, this particle will be attracted by the particles it has this side, because this whole bulk is completely filled with particles, right? It will be attracted from this side as well, from this as well, this as well, this. So can I say that this is completely balanced? Completely balanced. So it is stable. So it is completely balanced and it is stable, right? Yes. Now let's talk about the particle on the surface. If you talk about the particle on the surface, it will experience a force this direction, it will experience a force in this direction, it will experience a force this direction, this direction, this direction, this direction. But it does not have any particle above to experience a force. And that is why, can I say that it is unbalanced? And since it is unbalanced, so it is unstable. It has high energy. Because in chemistry, the particles which are unstable, unbalanced, they have high energy. And they want to be stabilized. And that is the reason, adsorption happens. Because once the particle will come here, it will experience equal force and it will start feeling balanced. Okay. And that is the reason your adsorption happens, because you have unbalanced particles or unstable particles on the surface of the adsorbate. Okay. Yes, perfect. Of the adsorbent, I am sorry, right? I hope you get the point that why your adsorption happens. See, I can make you understand the concepts. You can understand the concepts and then read the NCERT, so that you will read the theory and you will get every point. I cannot make you write each and every point, because then you will not be able to cover all the topics. So I'll make you understand each point, but then you'll have to read the NCERT to be thorough with each and every point. Okay, yes, perfect. So for this, you have to read NCERT. Okay, perfect. So this is how you will balance everything out. Okay, perfect, my dear students. So please write it down. Why adsorption happens? I hope you've written it. Now let's move forward. Now, the next basic term that we need to understand is absorption. What is absorption? So now, my dear students, I talked about absorption, I talked about adsorption. What if a body is such that adsorption is also happening and absorption is also happening? So a process in which adsorption and absorption both takes place, that is known as absorption. So we say that here adsorption and absorption takes place simultaneously. Okay, so here, though both the processes takes place simultaneously. I hope you're clear with this. Perfect. Now we can move forward, and now let's talk about occultation. What is occulation, my dear students? I told you that you have a adsorbate and you have adsorbent. Now, adsorbate can be gas, solid, liquid. Adsorbent can be solid, liquid, gas, right? Yes, they can have any of the three states of matter. So now, when you talk about occulation, my dear students, it is a specific term. It is a specific term for a process where your gas particles are adsorbed on the solid surface. Let's take an example. Let's say you might have heard about this reaction. You might have heard about this reaction, that is hydrogenation, where you have C2H4, you have H2, both of them are gases, and nickel is your solid, and nickel here acts as a catalyst. The catalyst actually provides a surface where your this gas and this gas, both of them get adsorbed on nickel solid. Okay, so this process is a example of occultation, where your adsorbent is your nickel solid and your adsorbate are these two reactant gases. Okay, so this is what is known as occultation. Please write it down, then we'll move forward. So now let's try and read whatever we have discussed till now. It says that in adsorption, the substance is concentrated only at the surface and does not penetrate in the bulk of the adsorbent. It does not go inside the body. Okay. Next is, in adsorption, the substances is uniformly distributed throughout the bulk of the system. But if you talk about absorption, it goes inside the bulk of the system. So this is the basic difference between adsorption and absorption. If you want to write it, please write it down. Now let's talk about the few examples. Now here are few examples of adsorption, absorption and sorption, my dear students. One is silica gel adsorbs water vapors while anhydrous CaCl2 absorbs it. You might have heard about silica gels. Silica gels actually adsorb water on their surface, only on the surface. But if you talk about anhydrous CaCl2, it is deficient of water. So whenever anhydrous CaCl2 comes in contact of water, it absorbs it. That is in the bulk of the body. So this is an example. Then you might have seen that ad, my dear students, that Pond's ad, where the ad was like, you have a face wash made up of charcoal, black Pond's charcoal face wash. Okay, they say that you just go around for the whole day, you have a lot of dust on your face, and when you use your charcoal face wash of Pond's, what charcoal actually does, they show that it just adsorbs all the dust on its surface, because charcoal actually has a very good adsorption capacity. So charcoal adsorbs. Okay, so this is how they have shown charcoal adsorbs ammonia gas while water absorbs it. Okay. Next, dyes adsorb as well as absorb on the cotton fibers. Now see, if you have a colored solution, let's say you have water and you have added some color to it, some dye to it. If you will put a cotton into it, what will happen? The cotton will adsorb on its surface, also it will absorb. So this is an example of sorption. Okay, but if I use the dye and I add the charcoal to it, my dear students, charcoal will only adsorb the dye on it, it will not absorb the dye on it. Okay, so this is the basic difference between adsorption and absorption. There are the few examples, and also you have to read NCERT for this, and only examples of NCERT are important. Other than that, no one will ask you any other example. Okay, perfect. Please write it down. I'll have some water and then we'll move forward. Okay, I hope you've written it. Okay, now we can move forward. Now let's talk about another important topic, which is thermodynamics of adsorption. Now we need to understand the thermodynamics of adsorption. Okay, in thermodynamics, we'll be discussing first about the delta enthalpy, which is delta H. Okay, so now, my dear students, I just want to make you understand here that whenever a bond is formed, energy is released. Okay, so you can write it here: when a bond is formed, energy is released. Energy is released. And if energy is released, this means that delta H is negative. Whenever a bond is formed, energy is released, it is given out, and that is the reason your delta H comes out to be negative. Whenever a bond is formed, when a bond is formed, energy is absorbed. And since energy is absorbed, delta H comes out to be positive. Now try to understand it. Now try to understand. Whenever, my dear students, energy is, now see, you and your friend are best of the friends. Okay. So if anyone wants to break your bond, if anyone wants to break your friendship, they'll have to give a lot of thought to it, a planning and plotting. That is, they will need a lot of energy to break the bond, right? Yes. So whenever a bond is broken, a lot of energy is required. A lot of energy is required. So whenever a bond, I'm sorry, whenever a bond is not formed, whenever a bond is broken, whenever a bond is broken, energy is absorbed. Okay, obviously, if you want to break a bond, you need to give a lot of energy. So energy delta H is positive. But whenever a bond is formed, if a bond is formed, if a friendship is formed, then, my dear students, energy is released because they become stable. Okay. So this is the difference that you need to understand, that whenever a bond is formed, energy is released. And whenever a bond is broken, energy is absorbed. Okay. I hope you're clear. Perfect. Please write it down and then we'll move forward. I hope you've written it right. Yes. Now, my dear students, if a reaction, let's say you have A plus B reaction, which is giving you C product, and if its delta H value comes out to be negative, we say it is a exothermic reaction. We say it is a exothermic reaction. Why exothermic? Because energy is released. Okay. So we, if we want to draw the heat, we'll say heat is released. So heat will be in the product side. But if my dear students, A plus B plus heat, if the heat is here, my dear students, then we say that delta H is positive. That is energy, and this reaction is known as endothermic. And why do we call it as endothermic? Because energy is absorbed here. Okay. So now I hope you have the idea about the enthalpy, what type of reaction it is known, if it has a particular kind of enthalpy. Now let's try to understand about the adsorption. If you talk about adsorption, my dear students, what will you say? You have a surface here, right? You have a surface here and your particles are coming and they are getting adsorbed on the surface. So since in adsorption, new interactions are formed, because initially there was no interaction, but the particles came and got adsorbed on the surface. So can I say that new interactions are formed? New interactions are formed in the process of adsorption. And since new interactions are formed, so can I say that delta H is actually equal to, since it is formed, so delta H will be negative, because whenever a new bond is formed, energy is released. So your delta H value will be negative, right? Yes. So in adsorption, my dear students, always and always the enthalpy change is negative because new interactions are formed. Okay. Yes. Perfect. If you want to write it, please write it down and then we'll move forward. I hope you've written it. This was the first thermodynamic term which we understood. Now we'll be understanding the other thermodynamic term. The other thermodynamic term is entropy, and entropy change is given by delta S. Now, what is entropy change? We need to understand that. Now, my dear students, your entropy change or entropy is actually a measure of randomness. So, it is a measure of randomness. So it is a measure of randomness. Okay. So if you talk about the entropy change, which is a measure of randomness. So the more the randomness, the more positive, the more the randomness will increase, the more the positive value for entropy change, right? Yes. So now imagine my dear students, you're talking about adsorption. So you had a surface here. You had particles which were completely random, moving randomly, right? Yes. Then they came and they got absorbed on the surface. Now, when they got adsorbed on the surface, their randomness actually decreased. Initially, they were free. They were free to move anywhere. They had the most random factor. Okay. But as they got adsorbed, they got a particular position and now their randomness has decreased. Since the randomness is decreasing, can I say that the entropy change is negative? Yes. So we can say that entropy change here is always negative. In adsorption, my dear students, since randomness is decreasing, your entropy change will be negative. Your entropy change would be negative. I hope you are clear with this. Please write it down and then we'll move forward. Okay. I hope you've written it. Now let's talk about the Gibbs free energy change. We know the enthalpy change. We know the Gibbs free energy change. Sorry, entropy change. Now you know how you give the Gibbs free energy change. There is a factor. There is an equation which is known as delta G is equal to delta H minus T delta S, and the name of this reaction is Gibbs-Helmholtz equation. So Gibbs-Helmholtz equation. This equation gives you the relation between Gibbs free energy change and the two enthalpies. Enthalpy and entropy we have discussed till now. Okay, so now this is how you get the Gibbs energy change. Now, my dear students, you might have heard somewhere that if your Gibbs free energy change delta G is positive, your reaction is non-spontaneous. Whenever for a process your delta G naught is positive, it is non-spontaneous, and whenever for a process your delta G is negative, it is spontaneous. Right? Yes. Now we will be finding that whether an adsorption process is spontaneous or non-spontaneous, what will be the conditions for a process to be spontaneous and non-spontaneous. Now we'll be studying that. Please write it down and then we'll move forward. How will we study that, my dear students? Now, I know that delta G is equal to delta H minus T delta S. Okay. Now, we just now studied that delta S is negative. It is negative for adsorption. And also your delta H value is also negative for adsorption always, right? Yes. So now, my dear students, for delta G to be negative, you always and always need delta H to be more than T delta S. You always want delta H to be more than T delta S. If you have delta H more than T delta S, because this is a negative value, and negative value multiplied by a negative, this whole value will be a positive value. And for delta G to be negative, your delta H should be more than this value. Only then your delta G will be negative. That is, only in this case your reaction will be spontaneous. So it is spontaneous at low temperatures. At low temperatures. So can I say that adsorption actually is spontaneous only at low temperatures and not at high temperature? Right? Yes. And delta G is equal to delta H minus T delta S. Just in case, my dear students, your delta H came out to be less than T delta S, your delta G will come out to be positive and it will be non-spontaneous. So it will be non-spontaneous. Okay. So these are the few cases that you need to understand. These are the few cases that you need to understand about the enthalpy. Okay. When is adsorption spontaneous? Only at low temperatures, because at only low temperatures, your delta H will be more than T delta S. Okay. Yes. Perfect. Please write it down and then we'll move forward. I hope you've written it. Now let's move forward. Now, the next topic which we will be discussing is that the factors that affect the adsorption of gases. Now try to understand this, my dear students. If you have a smaller surface, obviously lesser of the gas will be adsorbed. If you have a larger surface, there will be more surface for adsorption, so more adsorption will take place. So if you talk about surface area, can I say that surface area is actually directly proportional to adsorption. The more the surface area, the more will be the adsorption. The less the surface area, the lesser will be the adsorption, right? Yes, perfect. So please write it down. Now, if we talk about temperature, you know that whenever adsorption occurs, we generally talk about the physical adsorption. I'll tell you what is physical adsorption and what is the other type of adsorption. For now, we are understanding only physisorption. So, for physisorption, the interactions are very weak, okay. So, if you have a surface on which your gaseous particles have adsorbed, okay. Now, let's try to increase the temperature. If you will increase the temperature, the gas particles' kinetic energy will start increasing. And if their kinetic energy will start increasing, they'll start going out. That is, desorption will take place. So, can I say that lesser the temperature, more the adsorption, more the temperature, lesser the adsorption. So your temperature is actually inversely proportional to adsorption. It is inversely proportional to temperature. More the temperature, less the adsorption. Right? Yes, perfect. I hope you're clear with this. Please write it down and then we'll move forward. So till now we have discussed two factors. Now we'll discuss next two factors. The next two factors are, first is pressure. Now try to understand that how will pressure affect the adsorption process. See, imagine you are in a room, okay. So if somebody will push you in the room, you'll come into the room like this, okay. Let's say more and more people are getting pushed into the room, they'll start coming to the room, okay. Yes, so more the pushing, more is the adsorption, that is more of the people are coming on the in the room. Once the room is completely filled, now no more people can come. Now what is happening? They'll try even more, they'll push even more, right? Yes, then a few 2 or 3 people can be adjusted here and there, right? Yes, the same way things happen for adsorption. Let's say you had a surface and you had particles here. You increase the pressure, the more you will increase the pressure, the more the particles will adsorb. Now it is coming out to be most of the particles got adsorbed on the surface. Now you increase even more pressure, then obviously a few more of the particles will get absorbed because in the empty space which was left, right? Yes. So can I say that the more the pressure I'm applying, the more the adsorption is taking place? Yes. So your pressure is directly proportional to adsorption. The more the pressure, the more will be the adsorption. This is the general case. I'll make you understand the other cases as well. But till now, I hope you've got this point. Okay. Now let's talk about the nature of the gas. Now let's talk about the nature of the gas. See, if a gas has the tendency to liquefy, that is, if a gas has that attractive force of interaction, then the more the attractive force of interaction, the more easily it will form a bond or the interaction, and the more easily it will get adsorbed, right? Yes. If you remember states of matter, you might remember that gases have van der Waals constant A value. The more the A value, the more the A value, the more is the force of interaction. And the more the A value, the more the force of interaction, the more the adsorption of gas. And all of you remember or not, I don't know, but every gas has a critical temperature Tc, which is given by 8A upon 27 RB. 8A upon 27 RB. Okay. And this is how the critical temperature is given. The more the A value, the more will be the critical temperature. So I can say that more the A value, more will be the critical temperature, the more the adsorption will take place. And in this particular chapter, you will be given this critical temperature values of the gases. So you only have to compare the critical temperature values. The more the critical temperature, the more easily the gas can liquefy, the more easily the gas will be adsorbed on the surface. Okay, so this is how you can find out the dependence of the gases critical temperature on the adsorption process. Okay, Yes, perfect. I hope you're clear with this. Please write it down and then we'll move forward. I hope you've written it, right? Yes. Now let's move forward, my dear students. Now we will be discussing about another very important thing that we have gotten a better idea of adsorption. Now we will be understanding that how many types of adsorptions actually can be present. So if you talk about adsorption, your adsorption is majorly of two types. One is chemisorption and the other is your physisorption. These are the two names which you will come across. Physisorption. So what is the difference between these two, my dear students? I just want to make you understand this. If you talk about physisorption, it is a type of adsorption in which the force of interaction is chemical bonds. That is because of reaction, bonds are formed, and that process is known as chemisorption. But if you talk about physisorption, in physisorption, my dear students, there are no strong forces, there are no chemical bonds, there is only weak van der Waals interaction. So the major difference is that here are chemical bonds present, and here weak van der Waals interactions are present. Weak van der Waals interactions are present. Okay, this is the major difference between chemisorption and physisorption. I hope you're clear with this. Please write it down and then we'll go through the difference between these two in detail. Okay, yes, please write it down. I hope you've written it. Now let's try and understand each and every one point very clearly. So what the first point says, that it arises because of weak van der Waals forces. Perfect. It has weak van der Waals forces. It is caused by the chemical bond. So it has strong chemical bonds in it. Now, my dear students, your physisorption is reversible in nature. It is reversible in nature. Why is it reversible in nature? Now try to understand. You always have to take the example that in physisorption, my dear students, there are weak van der Waals interactions, the interactions which can be broken very easily. Okay. So what happens is few of the gas particles are on the surface and the interaction is very weak, so they go back and the other gas particles can come. So this way a reversible process can take place. Because the interactions are very weak. Whereas if you talk about chemisorption, it is highly specific in nature. Once the chemical bond is made, can it be reversed? No, you cannot just break the bond on your own. You cannot reverse it because chemical reaction has taken place. So it is reversible, but it is very specific. Okay, I hope you got this point. Let's talk about the other point. You will get time for everything. So this is not specific in nature. This is highly specific. This is reversible in nature. This is irreversible in nature. Okay. Next. It depends on the nature of the gas. Obviously, it depends on the nature of the gas. The gas which has higher critical temperature, that will be easily liquefied, so it will be easily absorbed. Okay, adsorbed. So it depends on the nature of the gas. More easily liquefiable gases are adsorbed readily. This also depends on the nature, but it depends on the gas which will react and form chemical bond. So this also depends on the nature of the gas. The gases which can react with the adsorbent show chemisorption only. Okay, perfect. I hope you've got this point. Now, since the interaction is very weak, so the enthalpy of adsorption is also very weak. Obviously, since the enthalpy is weak, so the breaking of the bond or the making of the bond will only have 20 to 40 joules of energy. But since here are chemical bonds, strong bonds, so the enthalpy is from 80 to 240 kilojoule per mole. Okay, yes, I hope you got these points. Please write it down and then we'll move forward. Okay. You need to understand and remember each and every point because you will definitely be asked questions from these differences. Okay. I hope you've written it. Now let's move forward. The next point. See, physisorption. In physisorption, my dear students, what actually happens is Low temperature is favorable for adsorption. It decreases with the increase in temperature. I hope you're clear because the interactions are very weak. So if you will increase the temperature, the particles' kinetic energy will increase and they'll start moving away. So the adsorption will decrease. So the plot for this particular graph is something like this. This is the adsorption. This is the temperature. It just decreases with the increase in temperature. Okay. Yes. Maximum adsorption, you will increase temperature, particles will start moving away and the adsorption will decrease. But for chemisorption, the plot is something like this. This is adsorption. This is time. It starts on increasing at one saturation point. After that, it keeps on decreasing. You know that reactions occur at a particular temperature. So, reactions take place at high temperature. So, you will increase the temperature. The reaction will happen. Adsorption will take place. So, with increase in temperature in chemisorption, your adsorption increases. But at a particular point, this point, the reaction took place. Adsorption happened. Now, if you will try to increase the temperature, then the bonds will start breaking and the adsorption will decrease. But in physisorption, always with increase in temperature, your physisorption will decrease. This is a very important point. If you want to mark it, question will be asked from this point. Okay, please write it down and draw the graph. Let's talk about the other point. No appreciable activation energy is needed. Again, my dear students, since there is no reaction, no activation energy is needed. Since reaction occurs here, so yes, activation energy is needed here. So high activation energy is needed sometimes. Okay. Next. It depends on the surface area. If you increase the surface area, the more the surface area, the more will be the adsorption. Yes, it depends on the surface. It increases with an increase on the surface area. Exactly. This will also happen. It also depends on the surface. It too increases with the increase of the surface area. You will have a more of surface area for the reaction to happen. Obviously, more of the chemisorption will take place. Okay. Next, it results into multi-layers. Now, since the interactions are not specific, imagine a few of the particles are sitting here, a few of the particles will be sitting above it, and few of the particles can sit above it because the interactions are very weak, van der Waals interaction. So, the physisorption is multi-layered. Multi-layers can be formed. But since in chemisorption, chemical reaction happens and chemical bond will be formed only with few particles, so only one layer is formed, not the multi-layered. So, this results in multi-molecular layers or adsorbent surface under high pressure. It results into a unimolecular layer only. Okay. Yes, perfect. I hope you've got the point. Please write it down. These are the few points which are very important. Okay, so I hope you've written it. Now let's move forward. Okay, so now my dear students, we'll be discussing about another topic, which is the Freundlich adsorption isotherm. So what is Freundlich adsorption isotherm? For that, you need to understand a very little thing. Now, imagine you have a surface here. Okay, so now my dear students, imagine what actually Freundlich isotherm does is it just shows you that how your adsorption depends on the pressure, how your adsorption increases with increasing pressure but at some extent, and after that what happens, everything is given to you by the Freundlich isotherm. So what happens is, you have a surface and you start increasing the pressure. Now, if you have a surface and you start increasing the pressure on the gas to get adsorbed on the surface, what will happen? Obviously, more and more of the gas particles will start getting adsorbed on the surface. Okay, so I can say that the pressure will increase, the adsorption will definitely increase. Okay, so if I want to draw a plot, can I draw the plot like this? That I have... So I'll have to draw the plot with you. So how am I going to draw the plot with you? Imagine we are going to draw a plot like this. Okay. So this is X upon M and this is pressure. Now you need to understand what is X and what is M and what is X upon M. So X is the amount of adsorbate. What is X? X is the amount of adsorbate that is getting adsorbed. Okay. What is M? It is the amount of adsorbent on which adsorption takes place. So what will be X upon M? X upon M will give me the amount of adsorbate getting adsorbed on a particular amount of adsorbent. So can I say that it is the extent of adsorption? right? Yes. And what is P? P is the pressure applied. Okay, so P is the pressure. Now let's try to understand it. Okay, so now my dear students, you know that you will increase the pressure, the extent of adsorption will increase, right? Yes. So for the static part, let's say this is O. From O to A, the more you will increase the pressure, the more the adsorption will increase. Okay, so ma'am, I can say that adsorption is directly proportional to the pressure. Okay, so now imagine you have reached a point where most of the particles have acquired the complete surface. Now what will happen? Now you will apply even more pressure. Still, only a few particles will be able to make their position in the empty spaces which are left. Okay, so can I say that now you'll have to apply a lot, even more pressure for a small extent of adsorption. So now I cannot say that the more the pressure I'm applying, the more the same exponentially, the same rate my adsorption is increasing, because the surface available for adsorption has become less. So now the more the pressure you're applying, a very small extent of adsorption is taking place. So now the plot will be something like this. From this point to this point, it will not be directly proportional. You will have to apply pressure more, but the adsorption will be very less. So this is from A to B point. Okay, now once the complete surface is occupied, and now you apply how much pressure you want, you apply, but no more particles can be adsorbed on the surface, right? Now you're increasing the pressure, but no adsorption is taking place. So the next point would be, can I draw it with the pink color? The next would be that you are increasing the pressure, but your adsorption is constant. No more adsorption can take place. Okay, so this is the actual dependence of your adsorption. This is the actual dependence of your adsorption on the pressure applied. And this was given by Freundlich. Freundlich gave the relation. Freundlich gave the relation between the adsorption and pressure by giving an equation that is X upon M is directly proportional to the pressure raised to the power 1 upon N, where N is a constant value. Okay, this was the relation given to you by Freundlich. Okay, so now we will be understanding this. Okay, so this was the plot. I just made this plot for you. The experimental isotherms always seem to approach saturation at high pressure, so they have reached a saturation point at high pressure. This cannot be explained by Freundlich isotherm, so that is the reason. So this was the drawback. We'll talk about the drawback later, but we have got the idea that this is something that is happening. So I'll write this in the next page. So this is X upon M is directly proportional to P raised to the power 1 upon N. So X upon M will be equal to proportionality constant P1 upon N. Okay. So now my dear students, what I can say that for O to A, I know that X upon M is directly proportional to P. Right? Yes. So for this particular point, your 1 upon N constant is actually equal to 1. Right? Yes. Perfect. Next, my dear students, this is your case 1. What is your case 2? For A to B. For A to B. This is from O to A. So for A to B, if you see, it is not directly proportional, so we cannot say it is 1. So we'll say that X upon M is directly proportional to P power 1 upon N, and 1 upon N is between 0 and 1. Okay, I hope you're clear with this. Now let's write the third case, case 3. From B to C. If you see from B to C, I can say that X upon M is not depending on pressure. It is a constant value. So your X upon M is actually constant. Okay, right? So for this time, I can say that your 1 upon N is actually equal to 0. Your 1 upon N is actually equal to 0. So this is how he gave the values for different plots. Okay, yes. So now I can say that for this part, X upon M is equal to K P power 1. For this part, I can say x upon m is equal to kp power 1 upon n, and for this particular part, your x upon m is equal to some constant k. Okay, so this is how Freundlich gave the relation between the pressure and the extent of adsorption, and this is your Freundlich adsorption isotherm. I hope you're clear with this. Please write it down. Then this, then this, then this. Okay, now only a very small thing is left, which is graph. Now let's try to plot a graph. Now let's try to plot a graph. We know that from Freundlich adsorption isotherm, x upon m is equal to kp power 1 upon n. Okay, so now let's take log on both sides. Okay, so taking ln on both sides, what will happen? Ln of x upon m will be equal to ln of kp power 1 upon n. You know that natural log of x into y is actually equal to natural log of x plus natural log of y. So we are using ln of x into y is equal to ln of x plus ln of y. So this will come out to be ln of x upon m is equal to ln of k plus ln of p 1 upon n. Whenever you talk about ln of x power n, you can write it as n ln x. So now we'll be using this. So your ln of x upon m will be equal to ln of k plus 1 upon n ln of p. Right? Yes. Now let's compare it with the straight line equation y is equal to c plus mx. So if we plot a graph, what will we get? This is your y-axis, so ln of x upon y will give you, x-axis is your ln of p. Okay, so this is ln of p. It will give you a straight line with a positive slope and a positive intercept. So it will be something like this, and the intercept would be ln of k, and your slope would be, which is actually equal to m is equal to tan theta, and this is actually equal to 1 upon n. So whenever you are given a plot of ln of x upon y, ln of p, the slope will give you the value of 1 upon n, and eventually you will understand that at which point in the graph are you, right? Yes. So this is how we understand the plot. Okay, yes, perfect. I hope you're clear with this. This is something very important, my dear students. Please note it down. Questions are generally asked from this particular part. I hope you've written it. Yes. Now, my dear students, let's try to solve a few questions, and then we'll solve a lot of questions in the next class. Okay, so first let's try to understand what we have studied till now. The question says that adsorbed acetic acid on activated carbon is, see, it says that you have a activated carbon, and your acetic acid is getting adsorbed on the activated carbon. So what will you call this acetic acid? The one which is getting adsorbed is known as adsorbate. Okay, so it is adsorbate. So option D will be your correct answer. So option D will be your correct answer. A direct question. Generally questions are asked like this. Okay, I hope you're clear with this. Please write it down. Let's move forward. Next question. Adsorption due to strong chemical forces is called. The adsorption which is due to the strong chemical forces, it is known as, strong forces are when chemical bonds are formed, and when chemical bonds are formed, it is chemysorption. So it is chemysorption. So option A will be your correct answer. So option A will be your correct answer. Okay. Perfect. I hope you're clear with this. Perfect, my dear students. With this, let's end our session today. So now, my dear students, what your homework for today is, you'll have to read the NCERT part of whatever we have discussed today. And then you'll come in the next class, because then we'll solve a few questions and we'll have a grasp on what we have studied till now. It is a theoretical chapter, so you need to read the NCERT for this. I am telling you, be it NEET paper, be it JEE mains paper, or be it CUET, my dear students, you need to read NCERT for this. Okay? Yes. So I hope all of you will study and come in the next lecture. I hope you've understood everything today. So, okay, please revise, do study. We'll meet in the next session. Till then, bye-bye. Take care. All the very best.